June 22nd, 1941, 03:15 hours. Soviet-German border. Operation Barbarossa, Germany's invasion of the Soviet Union, begins with the largest military assault in history. 3.8 million German troops, 3,350 tanks, 7,400 artillery pieces, and 2,770 aircraft crash across the border. The German tank commanders are confident. Their Panzer IIIs and Panzer IVs have conquered Poland in 35 days, France in 46 days, Yugoslavia in 12 days. German armour is proven. German tactics are superior. Victory seems inevitable. Then, near the town of Raseiniai in Lithuania, German tank crews encounter something unexpected. June 23, 1941. Raseiniai, Lithuania. Kampfgruppe von Zeckendorf, a German battle group advancing toward Leningrad, encounters a single Soviet tank blocking the road. It's a T-34, identifiable by its sloped armour and distinctive wide tracks. "Panzergranate!" armour-piercing round, orders the German tank commander. A Panzer IV fires its 75mm gun at 800 metres. Direct hit on the T-34's frontal armour. The shell bounces off. "Was? What?" The commander stares in disbelief. German 75mm guns have destroyed every Allied tank encountered so far. Polish 7TPs, French Char B1s, British Matildas. The shell should have penetrated. "Closer! 400 metres!" The Panzer IV advances, fires again. Another direct hit. Another ricochet. The T-34's armour is sloped at 60 degrees. German shells are deflecting rather than penetrating. The T-34 traverses its turret and fires back. Its 76mm F-34 gun roars. The German Panzer IV explodes, penetrated through the frontal armour at a range the German tank couldn't match. "Mein Gott," whispers the surviving German tanker. Over the next 2 days, this single T-34 blocks the road, destroying 12 German tanks and numerous support vehicles before finally being disabled, not by German tanks, which couldn't penetrate its armour, but by 88mm anti-aircraft guns brought up specifically to deal with it. When German engineers examine the destroyed T-34, they're stunned. June 25th, 1941. German Field Workshop. Oberst, Colonel, Wilhelm Ritter von Thoma, a veteran tank commander, inspects the disabled T-34. He dictates a report that will fundamentally challenge German assumptions about tank design. Initial assessment of Soviet T-34 tank. Armour. Frontal, 45mm thick, sloped at 60 degrees. Effective thickness, 90mm due to slope. German Panzer IV, 50mm frontal armour, vertical, no slope. German 50mm anti-tank gun, cannot penetrate T-34 frontally. German 75mm tank gun, penetrates only at close range, less than 400 metres. Armament, 76mm F-34 gun, long-barreled, high velocity. Penetrates all German tanks at 1,000 plus metres, superior to any German tank gun currently deployed. Mobility, wide tracks, 19.5 inches. Equals excellent ground pressure. Travels across mud, snow, terrain that bogs down German tanks. Speed, 35 miles per hour, adequate. Range, 250 miles, superior to German tanks. Engine, V2 diesel, 500 horsepower. Diesel equals less flammable than gasoline. German tanks use gasoline. Cold weather starting, superior to German gasoline engines. Overall assessment. This tank is superior to any German tank in service. Its armour cannot be penetrated by standard anti-tank weapons. Its gun penetrates all German tanks. Its mobility exceeds German tanks in Russian terrain. If the Soviets possess these in large numbers, our panzer forces face a crisis. Von Thoma sends the report to Berlin. The response comes quickly. Skepticism. "Impossible," declares a staff officer at OKH, German Army High Command. Soviet engineering is primitive. Their manufacturing quality is poor. This must be a prototype or limited production model. They cannot possibly produce sophisticated tanks in quantity. I am telling you, Fontoma responds. This tank is not sophisticated, it is crude. The welds are rough. The finish is poor. The interior is unfinished. But it works. And if crude but effective tanks exist in thousands, sophistication is irrelevant. The German High Command doesn't believe him. They will learn the hard way. The Soviet design philosophy, good enough right now. Kharkov, Soviet Union. Mikhail Koshkin, chief designer at the Kharkov Locomotive Factory, KHPZ, faces an impossible challenge. Design a tank that can be mass-produced by Soviet industry while defeating superior German armour. Soviet industrial capacity in 1938 is limited. Skilled workers, scarce. Stalin's purges eliminated many engineers. Precision manufacturing, limited. Advanced materials, unavailable. Production facilities, mostly converted tractor factories. Koshkin studies German and British tanks. They're sophisticated. Precision machined parts, complex transmissions, advanced optics, comfortable crew stations. We cannot build that, Koshkin tells his design team. We don't have the skilled workers. We don't have the precision equipment. We don't have the time. Then what can we build? Asks his assistant, Alexander Morozov. Something crude, something simple, something that works despite poor manufacturing, something that can be built in tractor factories by semi-skilled workers. Koshkin's design principles. 1. Sloped armour instead of thick armour. Thick armour requires expensive steel and heavy weight. Sloped armour deflects shells using geometry, not thickness. 45mm sloped at 60 degrees equals effectiveness of 90mm vertical armour. Uses half the steel, weighs half as much. 2. Diesel engine instead of gasoline. Diesel less flammable, crew survival. Diesel works better in extreme cold, Russian winter. Soviet industry produces diesel for tractors, existing infrastructure. 3. Wide tracks. Russian terrain, mud, snow, poor roads. Wide tracks equals low ground pressure equals mobility in mud. German narrow tracks equals high ground pressure equals bogged down in Russian conditions. 4. Simplified production. Cast turret instead of welded, easier to produce. Minimal interior fittings, uncomfortable but functional. Rough finish acceptable, function over form. Few spare parts, crews learn field repairs. 5. Powerful gun. 76mm F-34 gun, adapted from existing anti-aircraft gun. Cheap to produce, existing design. Powerful enough to defeat German armour. This tank will be uncomfortable, Koshkin admits. The crew will complain. German tanks have better optics, better instruments, better crew stations. But our tank will be cheap, simple, and effective. We can build 10,000 of them. Can Germany build 10,000 Panthers? No. Quantity defeats quality when the quantity is adequate and the quality is sufficient. September 1939. T-34 prototype testing. The first T-34 prototype undergoes field trials. Soviet tank crews provide immediate feedback. Complaints. The visibility is terrible. The commander's cupola is too small. The transmission is difficult to shift. It requires a sledgehammer. The interior is cramped and unfinished, sharp metal edges everywhere. The optics are inferior to German equipment. The ride quality is harsh, no suspension comfort. The gun sight is crude, difficult to aim accurately while moving. Koshkin listens to every complaint. Then he responds. Everything you say is true. The T-34 is crude, uncomfortable, and difficult to operate. Now let me ask, can it defeat German tanks? Yes. Can it travel across Russian terrain where German tanks cannot? Yes. Can it be produced in quantities German tanks cannot match? Yes. Then it is adequate. Perfection is the enemy of production. We build what we can build, not what we wish we could build. If you want a comfortable tank, join the German army. If you want to win, you drive the T-34. Stalin's approval. December 1939. Stalin personally reviews the T-34. He watches it demonstrate superior mobility, powerful armament, and sloped armor that defeats anti-tank weapons. How many can we produce? Stalin asks. Thousands per year, Comrade Stalin. The design uses existing industrial capacity. We can convert tractor factories to produce T-34s within months. Then produce them. Forget elegance. Forget comfort. Build them in overwhelming numbers. Quantity has a quality all its own. Production begins January 1940. By June 1941, when Germany invades, the Soviet Union has produced 1,225 T-34s. It's not enough to stop the German advance, but it's enough to shock the Wehrmacht into realizing they face an opponent with unexpected technological capability. July 1941. Army Group Center, Eastern Front. General Heinz Guderian, Germany's foremost tank commander, architect of Blitzkrieg doctrine, writes an urgent report to OKH after 2 weeks of combat. The T-34 tank represents a complete surprise. Our intelligence failed to warn us of this weapon's existence in significant numbers. Its capabilities exceed any Soviet tank we anticipated encountering. Frontal armor. Impervious to our 37mm and 50mm anti-tank guns at normal combat ranges. Only the 75mm gun can penetrate, and only at close range or from the flank. Armament. The 76mm gun penetrates our tanks at ranges exceeding 1,000 meters. Our tanks must close to 500 meters for effective return fire. Mobility. Superior to our tanks in mud and snow. While our panzers bog down, T-34s continue advancing. The tactical implications are severe. Our tank commanders must avoid frontal engagement with T-34s. We must rely on superior tactics, coordination, and crew training to compensate for inferior equipment. Recommendation: immediate development of new German tanks to match T-34 capabilities. The German Dilemma. August 1941. Kummersdorf Proving Grounds, Germany. German tank designers gather to examine a captured T-34. The inspection reveals uncomfortable truths. What German engineers admire. The sloped armor is brilliant, notes Dr. Ferdinand Porsche. 45mm at 60 degrees provides protection equivalent to 90mm vertical armor. Why didn't we think of this? The wide tracks. Look at the ground pressure. 10.6 psi compared to our Panzer IV's 14.8 psi. No wonder it doesn't bog down. The diesel engine. Less flammable. Better cold weather starting. More fuel efficient. The gun. This 76mm has better penetration than our 75mm short barrel, and they're mounting it in a tank that's faster and better protected. What German engineers criticize. The manufacturing quality is atrocious. Look at these welds, unfinished, rough. The interior is primitive, sharp edges, no crew comfort, terrible ergonomics. The transmission requires brute force to operate. The clutch is difficult. The optics are inferior. The gunner's sight is crude. The turret has only 2 crew, gunner and commander. Commander must also load the gun. This slows rate of fire. Dr. Porsche summarizes, this is a crude tank built by crude methods. But it is effective despite crudeness. The Soviets have achieved adequate performance through simplified design. They sacrifice sophistication for producibility. Can we copy it? Asks a Wehrmacht procurement officer. Copy the design principles, yes. Copy the production methods, no. Our industry is designed for precision manufacturing. Soviet industry accepts rough production because the design tolerates it. Our tanks require precision. Their tanks don't. The German response. 2 development programs begin. 1. VK30.01, Future Panther. Incorporate sloped armor, T-34 principle. Increase gun power to 75mm long barrel. Maintain German quality standards. Timeline, 24+ months to production. 2. Tiger tank, rushed development. Massive armor, 100mm plus frontal. Powerful 88mm gun, can penetrate any tank. Heavy, 56 tons versus T-34's 26 tons. Complex, expensive, difficult to produce. Timeline, 12 months to production. Both solutions share a fatal flaw. They cannot be mass-produced quickly. German tank production philosophy. Precision engineering, high-quality materials, complex systems, advanced optics, sophisticated transmissions, skilled labor required, low production rates, quality over quantity. Result: Germany can produce excellent tanks slowly or adequate tanks slowly. They cannot produce crude but effective tanks quickly because their industrial culture doesn't accept crude manufacturing. Soviet mass production, crude but fast. September 1941, Kharkov Locomotive Factory, KHPZ. As German armies advance toward Moscow, Soviet factories evacuate eastward, entire plants disassembled, loaded on trains, moved to safety in the Urals. The Kharkov tank factory relocates to Nizhny Tagil, 1,200 miles east. Within 90 days, production resumes in new facilities. T-34. Production methods: simplified assembly. Main armor plates: welded, not machined smooth, rough but functional. Turret: cast in one piece, crude finish but structurally sound. Interior: unfinished, painted metal, sharp edges, no padding. Wiring: exposed, not bundled, harder to maintain, faster to install. Worker training: minimal, 2 to 4 weeks for most positions. Many workers are women and teenagers, men at front. Precision not required. Design tolerates imperfection. Quality control: does it work? Not, is it pretty? Production speed. Tank factory manager Isaac Saltzman explains the philosophy. German Panther takes 55,000 man-hours to build. Our T-34 takes 3,700 man-hours. We sacrifice finish for speed. We sacrifice comfort for production rate. Every hour spent polishing welds is an hour not spent building another tank. The Germans build better tanks. We build more tanks. In 6 months, we will have built 5,000 T-34s. They will have built 500 Panthers. Who wins? Production statistics, 1941 to 1942. Soviet T-34. Production, 1941, 2,800 tanks. 1942, 12,520 tanks. Total, 15,320 tanks in 18 months. German Panzer IV production, comparable period. 1941, 3,073 tanks. 1942, 4,278 tanks. Total, 7,351 tanks in 18 months. Soviet production advantage, 2 to 1. And the T-34 is superior in armor, armament, and mobility to both German tanks. The Battle of Moscow. Quantity reveals its quality. December 1941. Outskirts of Moscow. German armies have reached the gates of Moscow. The campaign is behind schedule. Blitzkrieg tactics fail to achieve quick victory. Winter is approaching. Then, Soviet counteroffensive. 100 divisions, including 15 tank brigades equipped with T-34s, strike German positions. German After-Action Report, January 1942. The Soviet counteroffensive demonstrated the cumulative effect of T-34 superiority. Armor advantage. Our 50mm anti-tank guns cannot penetrate T-34 frontally. We must allow T-34s to approach within 400 meters before flanking shots become possible. By then, their 76mm guns have destroyed our positions. Mobility advantage. Snow and mud immobilize our tanks. T-34s with wide tracks continue advancing. We cannot maneuver. They can. Numerical advantage. We estimate 500 plus T-34s deployed in counter-offensive. Even when we destroy them, more appear. Our tank losses cannot be replaced quickly. Theirs can. Psychological advantage. Our crews fear T-34s. The knowledge that frontal engagement is suicidal affects morale. Crews hesitate, abandon positions prematurely. The combination of individual tank superiority and numerical superiority creates tactical situations where victory is impossible, despite superior German training and tactics. Why Crude works. The engineering logic. January 1942. Technical analysis. German engineers finally understand why the T-34's crudeness is actually strategic brilliance. Principle 1. Sloped armor defeats precision. German anti-tank gun, 50mm PAK-38. Penetration against vertical armor, 60mm at 500 meters. Penetration against T-34's 45mm sloped armor, 0mm, shell deflects. The T-34 uses geomatic, not thickness. Geometry is free. Thickness requires steel, weight, and cost. Result: T-34 achieves protection equivalent to 90mm armor using only 45mm of steel. Principle 2. Diesel survives gasoline engine. German tanks. Flashpoint, -45°C, ignites easily. Vapor flammability, extreme result, penetrating hit often causes fire. Diesel engine, T-34. Flashpoint, 55°C, difficult to ignite. Vapor flammability, low result, penetrating hit often doesn't cause fire. Soviet tanker survival rate, 15% higher than German, diesel reduces fire deaths. Principle 3. Wide tracks equals mobility. Ground pressure, force per square inch. T-34, 10.6 psi, wide tracks distribute weight. Panzer IV, 14.8 psi, narrow tracks concentrate weight. Russian terrain, mud, snow. T-34, maintains mobility. Panzer IV, frequently bogs down. Strategic result, T-34 can advance when Germans cannot. Mobility creates tactical opportunities. Principle 4. Simple equals fast. Production complex. German Panther, 55,000 man-hours to build, requires skilled labour, sophisticated components. Production rate, limited. Simple Soviet T-34, 3,700 man-hours to build, tolerates semi-skilled labour, crude but functional components. Production rate, high. Math. In time to build one Panther, Soviets build 15 T-34s. Principle 5. Adequate performance wins. T-34 is not the best tank in any single category. German tanks have better optics. German tanks have better crew comfort. German tanks have better finish quality. German tanks have better transmissions. But T-34 is adequate in every category that matters. Armour, adequate to defeat German guns. Gun, adequate to defeat German armour. Mobility, adequate for Russian terrain. Reliability, adequate for extended operations. Production, superior to any opponent. Result: adequate in overwhelming numbers defeats superior in limited numbers. The human cost of crude design. February 1942, Soviet Tank Training Center. Lieutenant Dmitry Lavrinenko, veteran T-34 commander, with 52 kills, trains new crews. He's brutally honest about the tank's flaws. The T-34 will try to kill you before the Germans do, Lavrinenko tells recruits. The transmission is difficult. You'll need a sledgehammer to shift gears. The interior has sharp edges. You'll cut yourself constantly. The commander's visibility is terrible. You'll struggle to see threats. The ride quality is harsh. You'll be bruised after every battle. Then why do we use it? Asks a recruit. Because it wins. The Germans have comfortable tanks with excellent optics and smooth transmissions. They're also dead because our gun penetrates their armour and theirs doesn't penetrate ours. Comfort doesn't matter if you're dead. Crude doesn't matter if you're alive. The T-34 is uncomfortable, difficult, and crude. It's also the reason we're winning. The casualty arithmetic. Soviet tank crew casualty rate 80%, high. Many deaths from tactical errors, poor training. Some deaths from design flaws, poor visibility, difficult escape. But diesel reduces fire deaths significantly. German tank crew casualty rate 75%, comparable. Many deaths from T-34 gun penetration. Gasoline engines increase fire deaths. But better visibility and ergonomics help survival. The brutal truth. Tank warfare is deadly regardless of tank quality. The T-34's crudeness increases crew casualties marginally, but its numerical superiority and armour gun advantages decrease casualties strategically by shortening the war. Lavrinenko's assessment. Yes, the T-34 kills some crews through design flaws, but if we'd waited for perfect tank, Germans would be in Moscow. The T-34 is adequate now. Perfect tank that arrives later is worthless tank. Lavrinenko dies in December 1941, not from tank design flaw, but from German artillery. His 52 kills make him one of the most effective tank commanders of the war, all achieved in the Crude T-34. July 1943, Kursk salient, Soviet Union. Operation Citadel, Germany's last major offensive on the Eastern Front. The goal: encircle and destroy Soviet forces in the Kursk salient, regain strategic initiative. German forces deploy their answer to the T-34, the Panther tank. Panther specifications. Armour: frontal, 80mm sloped at 55 degrees, effective 140mm. Superior to T-34's 45mm sloped armour. Armament: 75mm KWK-42 gun, long-barreled, high velocity. Penetrates T-34 at 2,000 plus meters. Superior to T-34's 76mm gun. Optics: Zeiss optics, world's best. Superior gun sights, better visibility. Crew comfort: 3-man turret, commander, gunner, loader, ergonomic design, smooth transmission, vastly superior to T-34. The Panther is, in every technical measure, superior to the T-34. July 5, 1943. Panthers enter combat at Kursk. German tank commanders are confident. Finally, a tank that matches or exceeds the T-34. Then reality intervenes. The Panther's combat debut: a disaster. July 5, 1943. 04:30 hours, Northern Kursk salient. The 39th Panzer Regiment attacks with 200 Panthers, the largest deployment of the new tank. By 0600 hours, 45 Panthers have broken down before engaging the enemy. By 1200 hours, 82 Panthers are disabled or destroyed, most from mechanical failure, not enemy action. By end of day, only 43 Panthers remain operational, 78% attrition rate. Panther mechanical failures. Final drive failure. The Panther's transmission and final drives cannot handle the tank's 45-ton weight. Average failure rate: 150 kilometers before breakdown. Many Panthers never reach battle, they break down en route. Engine fires. Maybach HL230 engine runs extremely hot. Fuel lines and oil seals fail from heat stress. Engine compartment fires frequent. Transmission problems. Complex 8-speed transmission. Requires precision manufacturing. Rushed production equals poor quality control. Gears strip, clutches fail. Cooling system. Inadequate cooling for engine power. Overheating common in summer heat. Causes cascading failures. Oberstleutnant, Lieutenant Colonel, Karl Decker, 39th Panzer Regiment commander, sends desperate report. The Panther is mechanically unreliable to the point of uselessness. 2/3 of our regiment is disabled by mechanical failure, not enemy action. The tanks that reach combat perform well, superior armour and gun are evident, but they don't reach combat. We are fighting not the Soviets, but our own equipment. Soviet response. Soviet intelligence intercepts German communications about Panther failures. Marshal Georgy Zhukov reads the reports and laughs. The Germans have built a sophisticated tank that doesn't work. We have built a crude tank that does work. This is the difference between German and Soviet engineering philosophy. Their Panther is faster, better armed, better protected than our T-34, but if it breaks down before reaching battle, its superiority is irrelevant. Our T-34 is crude, uncomfortable, and mechanically simple. It reaches the battle. That is what matters. The Battle of Kursk, numbers win. July 5 to 12, 1943. Kursk salient. The Battle of Kursk becomes the largest tank battle in history. 8,000 plus tanks engaged over 2 weeks. German forces: 2,928 tanks and assault guns, including 200 Panthers, 89 Tigers, 2,639 Panzer III, IV superior individual tank quality, Panthers and Tigers, superior crew training, superior tactical doctrine. Soviet forces: 5,128 tanks, over 3,400 are T-34s. Inferior individual tank quality, mostly T-34s. Inferior crew training, many newly trained crews. Inferior tactical doctrine, less flexible than German. Advantage: Germany in quality, Soviet Union in quantity. July 12, 1943. Battle of Prokhorovka, the climax of Kursk. Approximately 850 Soviet tanks, mostly T-34s, attack 600 German tanks, including Panthers and Tigers, in close-range engagement. The battle is savage. T-34s close to point-blank range, 200 to 400 meters, where their inferior guns can penetrate German armor. German tanks attempt to maintain distance where their superior guns dominate. Result after 12 hours. Soviet losses, 300 to 400 tanks destroyed. German losses, 80 to 100 tanks destroyed. Tactically, German victory, 3-to-1 kill ratio. Strategically, Soviet victory. Germans cannot replace losses, Soviets can. General Hermann Hott, German 4th Panzer Army commander, assesses, "We won today's battle. We destroyed 3 Soviet tanks for every tank we lost. Our Panthers and Tigers proved superior when mechanically functional. Our crews demonstrated superior skill. But we lost strategically. We began this offensive with 2,928 tanks. We have lost 760. We cannot replace them. German industry cannot sustain these losses. The Soviets began with 5,128 tanks. They lost 1,600. They will replace them within 2 months. Their production capacity exceeds ours by 3-to-1. We are winning battles but losing the war. Superior individual tank quality cannot overcome inferior production capacity. The mathematics are against us." July 13, 1943. Hitler cancels Operation Citadel. Germany will never again launch a major offensive on the Eastern Front. Why the T-34 won? The production math. Tank production, 1943. Soviet Union, T-34, 15,696 tanks produced. Other types, 8,200 tanks. Total, 23,896 tanks. Germany, Panther, 1,768 tanks produced. Tiger, 647 tanks produced. Panzer IV, 3,379 tanks produced. Other types, 3,011 tanks. Total, 8,805 tanks. Soviet production advantage, 2.7-to-1. Cost comparison. Panther. Production time, 55,000 man-hours. Cost, 117,000 Reichsmarks. Complexity, high, requires skilled labour. T-34. Production time, 3,700 man-hours, 15 times faster. Cost, 193,000 rubles, approximately 32,000 RM equivalent. Complexity, low, tolerates semi-skilled labour. Cost effectiveness. T-34 costs 1/4 of Panther to produce, takes 1/15 the time. The attrition equation. For every Panther Germany builds, Soviet Union builds 15 T-34s. In combat, one Panther might destroy 3 T-34s before being knocked out, favourable kill ratio. But 15 T-34s destroy the Panther, and 12 T-34s survive. Net result? Soviet advantage grows. Even with superior kill ratios, Germany cannot win through attrition when outnumbered 3-to-1 in production. The reliability factor. August 1943, Comparative Reliability Assessment. Panther reliability, 1943. Average mechanical life, 150 kilometers before major breakdown. Most common failures, final drive, transmission, engine. Crew assessment, powerful when it works, but it rarely works. T-34 reliability, 1943. Average mechanical life, 1,000 kilometers before major breakdown. Most common failures, transmission, but field repairable. Crew assessment, crude but reliable. Always works when needed. Strategic impact. German Panther Battalion, 64 tanks. Combat readiness on average day, 35%, 22 tanks operational. Remainder, in repair, awaiting parts, or abandoned. Soviet T-34 Battalion, 64 tanks. Combat readiness on average day, 70%, 45 tanks operational. Remainder, in repair, but mostly field repairable. Result, Soviet battalion with inferior tanks fields more operational tanks than German battalion with superior tanks. A sophisticated tank that doesn't work is worse than a crude tank that does. The crew experience, German versus Soviet. German Panther crew testimony. Unteroffizier Hans Becker, gunner, 52nd Panzer Battalion. The Panther is a magnificent tank when it works. The optics are superb. The gun is devastating. The armour makes you feel invincible. The crew compartment is comfortable. But we spend more time repairing it than fighting in it. Final drive failures are constant. The engine overheats. The transmission fails. We average 1 combat day for every 3 maintenance days. Meanwhile, Soviet T-34s, crude, poorly made, just keep coming. We destroy 3, 5 more appear. We destroy those, 10 more appear. They don't stop. They don't break down. They just keep advancing. Our tank is better. Their tanks are more. In the end, more wins. Soviet T-34 crew testimony. Sergeant Alexander Bodnar, Commander, 5th Guards Tank Army. The T-34 is uncomfortable. Visibility is poor. The transmission requires a sledgehammer. The interior is unfinished metal that cuts you. The ride is harsh. But it works. Every day it works. We advance, we fight, we repair minor issues, we advance again. The engine is reliable. The gun fires every time. The armour protects us. German tanks are better in every way. Better optics, better ergonomics, better quality. But when we arrive at battle, we're there, and they're broken down on the road. What good is a better tank that isn't there? I'll take crude and present over sophisticated and absent. The winter test. T-34 supremacy. December 1943, Eastern Front, winter. Temperature, -35 degrees Celsius, -31 degrees Fahrenheit. German tanks in winter. Panzer IV startup procedure, winter. Light fires under engine to warm oil, 30 to 45 minutes. Manually heat coolant, 15 minutes. Attempt start, often fails, repeat process. Total time to operational, 60 to 90 minutes in extreme cold. Many German tanks cannot start in extreme cold. Gasoline engines require extensive preheating. Crews must keep fires burning under tanks overnight. T-34 in winter. T-34 startup procedure, winter. Turnkey, diesel engine starts, designed for Russian winter. Total time to operational, 2 to 3 minutes. The T-34's diesel engine, crude manufacturing, and simple systems are designed for Russian conditions. German tanks, sophisticated and precision-made, fail in extreme cold. Combat result. Soviet offensive, January 1944. T-34 units advance rapidly in -40 degrees Celsius weather. German tanks are immobilized, not by combat, but by weather. German after-action report. Soviet T-34s operated effectively in temperatures where our tanks could not start. The technological sophistication of our equipment becomes a liability in extreme conditions. Their crude but functional design is superior to our advanced but environmentally sensitive design. January 1944. Nizhny Tagil Tank Factory, relocated from Kharkov. Soviet engineers examine combat reports from thousands of T-34 engagements. The data is brutal but clear. The T-34 is winning through quantity, but casualties are higher than necessary. Chief designer Alexander Morozov, who succeeded Koshkin after his death in 1940, analyzes the problem. T-34 weaknesses identified. 1943 combat data. 1. Gun inadequacy emerging. 76mm F-34 gun adequate against Panzer III-4, inadequate against new Panthers and Tigers. Panthers can engage T-34s at 2,000 meters. T-34s must close to 500 meters to penetrate Panthers. Result: unfavorable exchange ratios against heavy German tanks. 2. Two-man turret. Commander must also load gun. Slows rate of fire. Reduces situational awareness. Commander distracted by loading. German three-man turrets. Commander, gunner, loader. More efficient. 3. Poor visibility. Small commander's cupola. Limited periscopes, inferior to German vision systems. Commanders struggle to spot threats. 4. Crew survivability. While better than gasoline-engine tanks, diesel T-34s still burn. Ammunition storage vulnerable. Crew escape difficult, hatches poorly designed. Morozov faces a decision. Should he redesign the T-34 to fix these flaws? The engineering answer is yes. The production answer is no. The redesign dilemma. Morozov presents two options to the State Defense Committee. Option A, complete redesign. New turret, 3-man crew. Improved visibility systems, better crew protection, enhanced ammunition storage, improved ergonomics. Timeline, 18 months development plus 6 months production transition. Impact, 0 new tanks for 24 months while factories retool. Risk, Germany could exploit production gap. Option B, incremental upgrade, T-34-85. Larger turret with 85mm gun, upgraded firepower. 3-man turret crew, commander freed from loading. Minimal other changes. Use existing production lines with minor modifications. Timeline, 6 months development plus 2 months transition. Impact, brief production slowdown then full capacity. Risk, minimal. Stalin's response, we don't need perfect tanks, we need adequate tanks right now. The Germans are retreating, we must maintain pressure. Incremental upgrade, keep producing. The T-34-85 program. The T-34-85 exemplifies Soviet pragmatism. Changes. 85mm ZIS S-53 gun, penetrates Panther at 1,000 meters. Enlarged turret, 3-man crew. Improved commander's cupola, better visibility. Radio moved for better crew access. Non-changes. Same crude hull construction, fast production. Same diesel engine, reliable, proven. Same transmission, difficult but functional. Same suspension, harsh but durable. Same rough interior finish, uncomfortable but cheap. Result. The T-34-85 remains crude, but addresses critical combat deficiencies without sacrificing production rate. T-34-85 combat debut. March 1944, Ukraine. T-34-85s enter combat against German forces equipped with Panthers and Tigers. First engagement report, March 15, 1944. Guards Tank Brigade equipped with T-34-85s encounters Panther Battalion near Kamenets-Podolsky. Previous result, T-34-76 versus Panther. Soviets lose 3 to 4 tanks per Panther killed. New result, T-34-85 versus Panther. Soviets lose 1 to 2 tanks per Panther killed. The 85mm gun makes the difference. T-34-85s can now engage Panthers at 1,000+ meters, instead of closing to suicidal 500-meter range. But the T-34-85 retains all the crude characteristics Soviet crews hate. The new turret is better, reports Tank Commander Dmitry Loza. 3-man crew improves effectiveness. 85mm gun gives us a fighting chance against Panthers. But the transmission still requires sledgehammer. Interior still unfinished. Visibility still inferior to German tanks. Ride quality still harsh. However, the tank works. It's available now. It's being produced in thousands. Sophisticated German tanks are wonderful on paper. Our crude but effective tanks are wonderful on battlefield. I'll take crude and present over perfect and absent. Production comparison. T-34-85 versus German heavy tanks. T-34-85. Production 1944 to 1945. 1944, 10,952 tanks. 1945, 12,551 tanks. Total, 23,503 tanks. German Panther production 1944 to 1945. 1944, 3,740 tanks. 1945, 507 tanks, production collapsing. Total, 4,247 tanks. German Tiger production, 1944 to 1945. Tiger 1, 1944, 623 tanks. Tiger 2, 1944 to 45, 492 tanks. Total, 1,115 tanks. Soviet advantage, 4.5 to 1 in comparable heavy-medium tanks. Even after Germany produces their T-34 killers, Panther and Tiger, Soviet production overwhelms German capacity. The reliability gap widens. Summer 1944, comparative operational readiness. T-34-85. Operational statistics. Average mechanical life, 1,200 kilometers, improved from T-34-76. Field repair time, 4 to 6 hours for typical breakdown. Spare parts, readily available, simplified design, standardized components. Operational readiness, 72%. On average, 72 of 100 tanks combat ready. German Panther, mid-1944, improved model. Average mechanical life, 250 kilometers, better than 1943, still poor. Repair time, 24 to 48 hours minimum, requires specialized parts tools. Spare parts, chronic shortages, complex design, bombing of factories. Operational readiness, 37%. Only 37 of 100 tanks combat ready. Strategic implication. Soviet tank army, 500 T-34-85s, 360 tanks operational on an average day. Can sustain operations continuously. German Panzer Corps, 500 Panthers Tigers, 185 tanks operational on an average day. Frequent operational pauses for maintenance. Result. Even when outnumbered 2 to 1, Soviet tank armies field more operational tanks than German forces nominally equal in strength. Crude but reliable defeats sophisticated but unreliable. The final push. Operation Bagration, June 1944. Belarus. Operation Bagration, Soviet offensive to liberate Belarus and destroy German Army Group Center. 2.3 million Soviet troops, 5,200 tanks, mostly T-34-85s. The operation demonstrates everything the T-34 philosophy represents. Soviet advantages. Numerical superiority. 5,200 Soviet tanks versus 800 German tanks, 6.5 to 1 advantage. Even accounting for German quality advantage, Soviets overwhelm through numbers. Operational readiness. Soviet tanks maintain 70% plus readiness despite continuous operations. German tanks struggle to maintain 40% readiness. Logistical simplicity. T-34 diesel fuel easier to supply than German gasoline. T-34 simplified maintenance reduces support burden. T-34 standardization means parts compatibility. Terrain mobility. Summer mud. T-34 wide tracks excel, German narrow tracks struggle. Poor roads. T-34 designed for it, German tanks bog down. Reliability. T-34s advance 300 plus kilometers in 2 weeks. German tanks break down, are abandoned, captured. Operation Bagration results, June 23, August 19, 1944. Soviet losses, 2,957 tanks destroyed, disabled. High losses due to aggressive tactics. German losses, 2,000 tanks destroyed, captured. More critically, Army Group Center destroyed, 28 divisions eliminated. 300,000 plus German casualties. Strategic collapse of German Eastern Front. Soviet assessment. Marshal Zhukov. We lost more tanks than the Germans, but we have more tanks than Germans. Our factories produce 15 T-34s for every Panther Germany builds. We can sustain these losses. They cannot. The T-34 is crude. Our crews complain constantly. But it works. It's available. It advances. Those 3 qualities matter more than sophisticated optics, comfortable crew stations, or precision engineering. Germany builds Tigers. We build tractors with guns. Tractors win. The German perspective. Defeat despite superiority. July 1944. German Army analysis. General Heinz Guderian, now Inspector General of Panzer Troops, writes assessment. Our tanks are superior in every technical measure. Panther armor, superior to T-34-85 Panther gun, superior to T-34-85. Panther optics, superior to T-34-85. Panther crew comfort, superior to T-34-85. Yet we are losing. Why? 1. Production. They build 4.5 tanks for every tank we build. 2. Reliability. Their crude tanks work, our sophisticated tanks break. 3. Sustainability. They can replace losses, we cannot. 4. Logistics. Their simpler tanks require less support. 5. Training. Their simplified design allows rapid crew training. We pursued technological perfection. They pursued adequate effectiveness at scale. In total war, they are correct and we are wrong. The T-34 represents a design philosophy alien to German engineering culture. We build quality, they build quantity. We build sophistication, they build simplicity. We build tigers, they build bulldozers. But war is not won by the best tank. It is won by enough adequate tanks in the right place at the right time. The T-34 is enough. The Panther is better, but enough beats better when enough arrives in overwhelming numbers. This is our fundamental strategic error. We assumed quality would overcome quantity. It does not. Quantity has a quality all its own, the quality of presence. A mediocre tank that is there defeats a superior tank that is absent or broken. We have lost the tank war not because our tanks are inferior, they are superior. We have lost because superiority without adequate quantity, reliability, and sustainability is strategically worthless. The crew's final word, December 1944. Sergeant Alexander Bodnar, veteran T-34 commander, 157 combat engagements, 23 kills. I have driven the T-34 for 3 years. I hate it. The transmission requires a sledgehammer to shift. The interior cuts you on sharp metal edges. The ride quality bruises you. The visibility is poor. The crew comfort is non-existent. German tankers have better equipment, better optics, better ergonomics, better everything. I've examined captured Panthers. They're magnificent, comfortable, well-made, sophisticated. But I'm alive, and most German tankers are dead. Why? Because my crude T-34 works. It starts in -40 degrees weather. It drives through mud. It absorbs damage. It's simple enough that I can repair it in the field with basic tools. And when it's destroyed, my country produces 3 more to replace it. The Germans built better tanks. We built enough tanks. In the end, enough wins. Would I prefer a Panther's comfort? Yes. But I prefer being alive more. The T-34 keeps me alive through crudeness, not despite it. Crude means simple. Simple means reliable. Reliable means I'm here to tell this story. Germany lost because they built tigers for a zoo. We won because we built tractors for a war. May 1945, Berlin, Reichstag. A T-34-85 sits in front of the ruined Reichstag building, Soviet flag flying from its turret. The tank's hull is scarred with dozens of hits, testament to combat, but it's still operational. Soviet war correspondents photograph the scene. The symbolism is perfect. A crude Soviet tank, built by semi-skilled workers in evacuated factories, manufactured in overwhelming numbers through simplified design, has driven 2,000 kilometers from Stalingrad to Berlin and delivered victory. Meanwhile, 200 kilometers west, American forces discover something revealing. The underground factory, May 1945, Nordhausen, Germany. US Army discovers the Mittelbau-Dora concentration camp and associated underground factories where V-2 rockets and other wonder weapons were produced by slave labor. They also discover something else, an enormous hidden factory complex designed to produce Panther and Tiger tanks, never completed. The unfulfilled plan. German documents reveal ambitious expansion. Planned production, 1,000 Panthers per month versus actual 300 per month. Required 50,000 skilled workers, unavailable, drafted or killed. Required specialized machinery, destroyed by Allied bombing. Required strategic materials, unavailable, supply lines cut. Timeline, 18 months to full operation, war ended first. The factory represents Germany's fundamental problem. They designed for sophisticated production that required resources, skills, and time they didn't have. Comparison to Soviet approach. Soviet tank factory, Nizhny Tagil. Production, 1,300 T-34s per month achieved. Workers, semi-skilled labor, women, teenagers, men at front. Machinery, basic tools, adaptable equipment. Materials, crude steel, Soviet metallurgy inferior but adequate. Timeline, 90 days from evacuation to resuming production. Soviet production worked because design accommodated limitations. German production failed because design required capabilities that didn't exist. The statistical verdict, June 1945. Allied intelligence assessment. British and American intelligence officers compile comprehensive analysis of Soviet versus German tank production and effectiveness. Total production, 1941 to 1945. Soviet Union, T-34, all variants, 57,350 tanks. Other tanks, 29,000 tanks. Total, 86,350 tanks. Germany, Panther, 6,000 tanks. Tiger I-2, 1,839 tanks. Panzer III-4, 16,322 tanks. Other, 8,000 tanks. Total, 32,161 tanks. Soviet production advantage, 2.7 to 1. Combat effectiveness. Kill ratios, German versus Soviet tanks, 1941 to 1942, 6 to 1 in German favour, German tactical superiority. 1943, 3 to 1 in German favour, T-34 evens odds. 1944, 2 to 1 in German favour, T-34 85, German advantages eroding. 1945, 1.5 to 1 in German favour, Soviet numerical superiority overwhelming. Strategic result. Even with consistently superior kill ratios, Germany lost because they couldn't replace losses while Soviet Union could replace losses 3 times over. The mathematics of attrition. Scenario. Germans destroyed 2 Soviet tanks for every German tank lost. Favourable kill ratio. Starting forces. Germany, 1,000 tanks. Soviet Union, 2,700 tanks. Historical production advantage. After engagement destroying all German tanks, Germany, 0 tanks remaining, all destroyed. Soviet Union, 700 tanks remaining, 2,000 destroyed, 700 survive. Even with 2 to 1 kill ratio favouring Germany, Soviet numerical superiority ensures victory. Allied conclusion. The T-34 was not the best tank of World War II in terms of individual capabilities. The German Panther was arguably superior in armour, firepower, and crew systems. The German Tiger was superior in armour and firepower. American Sherman was superior in reliability and crew comfort. However, the T-34 was the most effective tank because effectiveness equals individual capability times quantity times reliability times producibility. T-34 individual capability, good, not excellent. T-34 quantity, overwhelming. T-34 reliability, good. T-34 producibility, excellent. Combined effectiveness, superior to all opponents. The German engineering autopsy. US Army Ordnance Department interviews captured German tank designers. Ferdinand Porsche, designer of Tiger tank. We designed the Tiger to be the finest tank in the world. Superior armour, powerful gun, advanced engineering. It succeeded. The Tiger was feared by all Allied tankers. But we produced only 1,347 Tiger Is. The Soviets produced 57,350 T-34s. Even if each Tiger destroyed 40 T-34s, which was impossible, we still lose through arithmetic. The T-34 designers understood something we didn't. In total war, the tank that can be mass-produced matters more than the tank that is individually superior. They sacrificed perfection for production. We pursued perfection at the expense of production. Who was correct? History answers. They won, we lost. In war, that is the only measure of correctness. Heinrich Kniepkamp, designer of Panther tank. The Panther incorporated lessons from T-34, sloped armour, powerful gun, improved mobility. Technically, It was superior to T-34 in every way. But we couldn't produce it fast enough. We couldn't maintain it reliably. We couldn't supply it adequately. The design required precision manufacturing that became impossible as Allied bombing destroyed our factories and skilled workers were drafted. The T-34 design tolerated crude manufacturing. The Panther design required precision manufacturing. When Germany's industrial capacity degraded, the Panther became impossible to produce effectively. The T-34 continued rolling off assembly lines unchanged. This reveals the genius of Soviet design philosophy. They designed for the worst-case production scenario: semi-skilled labor, crude materials, limited tools. We designed for the best-case scenario: skilled labor, quality materials, precision tools. When war destroyed best-case conditions, our designs failed. Theirs continued working. The Soviet design philosophy validated. Mikhail Koshkin, posthumous analysis. Mikhail Koshkin, chief designer of the T-34, died in 1940 from pneumonia contracted during winter testing. He never saw his tank win the war. Post-war, Soviet engineers published comprehensive analysis of Koshkin's design decisions, validating every choice. Koshkin's Principle 1. Design for production reality, not engineering ideal. German designers asked, "What's the best tank we can engineer?" Koshkin asked, "What's the best tank we can produce?" Result: T-34 design accommodated Soviet industrial limitations. German designs exceeded German industrial capacity. Koshkin's Principle 2. Adequate performance, broadly distributed, defeats superior performance, narrowly concentrated. German philosophy: build small numbers of superior tanks. Soviet philosophy: build large numbers of adequate tanks. Result: superior German tanks were outnumbered 3-1 and overwhelmed. Koshkin's Principle 3. Simplicity enables sustainability. Panther: complex, requires specialist maintenance. T-34: simple, field maintainable with basic tools. Result: Panther operational readiness 35 to 40%. T-34 operational readiness 70% plus. Koshkin's Principle 4. Reliability multiplies numerical advantage. Even if two armies have equal tank numbers, the army whose tanks actually work has effective superiority. Soviet 1,000 T-34s at 70% readiness equals 700 operational tanks. German 1,000 Panthers at 37% readiness equals 370 operational tanks. Result: Soviets field nearly 2-1 advantage despite nominal parity. Koshkin's Principle 5. Design for war, not peacetime evaluation. In peacetime comparison, Panther superior in every measurable category. In wartime reality, T-34 superior in every strategic outcome. Result: peacetime specifications don't predict wartime effectiveness. The legacy: Cold War tank design 1950s. Post-war tank development. The T-34's lessons influence Cold War tank design worldwide. Soviet post-war tanks, T-54-55. Continue T-34 philosophy. Simple, crude, mass-producible. T-54-55 becomes most produced tank in history, 100,000 plus built, exported to 50 plus countries. Design philosophy: good enough in enormous quantities. Western post-war tanks, M48, Centurion. Adopt some T-34 lessons. Sloped armor becomes standard. But continue emphasis on quality, sophistication, crew comfort. Lower production numbers. Design philosophy: technical superiority with adequate numbers. Israeli assessment, 1960s-1970s. Israeli defense forces face Soviet-supplied Arab tank forces equipped with T-34s, T-54-55s, and T-62s, all following Soviet crude but effective philosophy. Israeli General Israel Tal. Soviet tanks are crude, poor optics, uncomfortable crews, rough finish, but they work. They're available. They're cheap enough that Arab states can afford hundreds. We field technically superior Western tanks. Better fire control, better optics, better crew systems. But we face numerical disadvantage because Western tanks cost 3 times Soviet tanks. The T-34 lesson persists. Crude but numerous can defeat sophisticated but scarce. We must win through superior tactics, training, and doctrine. We cannot win through superior numbers. The Modern Echo, 1991, Gulf War. US and coalition forces face Iraqi army equipped with Soviet-designed tanks, T-55, T-62, T-72, descendants of T-34 design philosophy. Iraqi tank force. T-72, most modern, sophisticated. T-62, adequate, reliable. T-55, old but functional. Total, 5,500 plus tanks. US coalition tank force. M1 Abrams, technologically advanced. Challenger 2, sophisticated. Total, 1,800 plus tanks. Result, coalition victory with 3-to-1 numerical disadvantage. Why? Technology gap too large. M1 Abrams could engage Iraqi tanks at 3,000 plus meters using thermal sights and advanced fire control. Iraqi tanks couldn't see Abrams at that range. But, critical difference from World War II. In World War II, German tanks were better, but not overwhelmingly better. T-34 could fight Panthers, Tigers, with reasonable chance of success if tactics were smart. In Gulf War, technology gap was so enormous that Iraqi numerical superiority was irrelevant. Abrams could destroy 10-plus Iraqi tanks before being engaged. Lesson modified. Crude but numerous defeats, sophisticated but scarce, only applies when technology gap is modest. When technology gap becomes enormous, quality defeats quantity. T-34 versus Panther. Modest gap. Quantity wins. Iraqi T-72 versus Abrams. Enormous gap. Quality wins. 2024. Ukraine War. Russia invades Ukraine. Both sides field tank forces. Russian tanks. T-90, T-80, T-72 variants. Continue Soviet crude but producible philosophy. Numerous but aging. Limited modernization. Ukrainian tanks. T-64, T-72 variants. Soviet legacy. Western-supplied tanks. Leopard 2, Challenger 2, M1 Abrams. Fewer but more capable. Critical factor. Anti-tank weapons. Modern portable anti-tank missiles, Javelin, NLAW, Stugna, are so effective that even large numbers of tanks become vulnerable. Russian tank losses, 2022-2024. 3,000 plus tanks destroyed, damaged. The T-34. Lesson inverted. In World War II, T-34's crude producibility enabled mass production that overwhelmed German sophistication. In 2024, even crude but numerous tanks are vulnerable to precision anti-tank weapons. Quantity cannot overcome portable precision weapons. New paradigm. Neither crude quantity nor sophisticated quality provides decisive advantage. Portable precision weapons neutralize both. The T-34 era is over. The age of mass tank warfare has ended. 2024. Kubinka Tank Museum, Russia. The Central Armed Forces Museum houses the world's most comprehensive tank collection. In the Soviet Hall, dozens of T-34s sit on display, different variants, different production years, each telling part of the story. The centerpiece, T-34 Model 1941, serial number 183-26348. This specific tank participated in the Battle of Moscow, Battle of Stalingrad, Battle of Kursk, and the drive to Berlin. It survived 4 years of continuous combat. Museum curator Dmitry Volkov explains to a group of visitors, this tank should not have survived. Statistically, T-34s lasted an average of 6 months in combat before being destroyed. This one lasted 4 years. It was knocked out 3 times, repaired in the field, and returned to service. Look at the armour, 27 penetration marks, hits that damaged but didn't destroy. The sloped armour deflected shells that would have penetrated vertical armour. The diesel engine survived fires that would have destroyed gasoline engines. The simple mechanical design allowed field repairs that would have been impossible with sophisticated tanks. A visitor asks, was the T-34 the best tank of World War II? Volkov considers carefully. Best? No. The German Panther was better in almost every measurable way. Armor, gun, optics, crew comfort. The American Sherman was more reliable. The British Churchill had thicker armor. But the T-34 was the most effective tank, because effectiveness isn't just performance. It's performance times quantity, times reliability, times sustainability, times availability. This tank won not because it was best, but because it was enough. Enough armor to defeat German guns, enough gun to defeat German armor, enough mobility for Russian terrain, enough reliability to reach battles, enough simplicity to be mass-produced. Enough beats best when enough arrives in overwhelming numbers. The Production Miracle Display. The museum's production exhibit tells the story of how crude design enabled mass production. Evacuated factories, 1941-1942. When Germany invaded, Soviet Union evacuated 1,523 factories eastward, including all major tank plants. The Kharkov tank factory moved 1,200 miles to Nizhny Tagil. Display shows photographs. Factories being disassembled piece by piece, equipment loaded onto trains, workers evacuating with machinery, factories reassembling in Ural Mountains. Timeline: 90 days from evacuation order to resuming production. How was this possible? Comparison display. If T-34 had been sophisticated, like Panther, specialized machinery required, cannot move easily. Precision tools required, cannot replicate quickly. Skilled labor required, cannot train quickly. Quality control required, cannot compromise. Timeline to resume production: 18 to 24 months, war lost. Because T-34 was crude, basic machinery sufficient, movable. Simple tools adequate, replicable. Semi-skilled labor acceptable, trainable in weeks. Quality control: does it work? Fast approval. Timeline to resume production: 90 days, war continues. The critical insight: Soviet Union survived 1941-1942 because T-34 design accommodated emergency production. If T-34 had required sophisticated manufacturing, evacuation would have meant zero tank production for 18+ months. Germany would have won. Crude design wasn't a flaw, it was a survival mechanism. The Crew Experience exhibit. Interactive display allows visitors to sit in T-34 interior and experience what crews faced. Inside the T-34, visitor climbs in. Immediate impressions: cramped, 4 men in tight space. Uncomfortable, hard metal seats, no padding. Sharp edges everywhere, unfinished metal cuts easily. Poor visibility, small vision ports. Claustrophobic, low ceiling. Audio plays actual crew testimonies. Sergeant Alexander Bodner, 157 engagements, 23 kills, survived war. The first thing you notice: it's uncomfortable. The seat bruises you. The interior cuts you. The transmission requires sledgehammer to shift. The noise is deafening. Engine, gun, ricochets. The heat is extreme in summer, freezing in winter. But you adapt. You learn to shift without the sledgehammer. You learn to avoid sharp edges. You learn to read vibrations and sounds to diagnose problems. The T-34 becomes part of you. German tankers had comfortable tanks, but comfortable tankers in burning Panthers are dead. Uncomfortable tankers in working T-34s are alive. I chose uncomfortable and alive. Contrast: German Panther crew testimony. Audio switches to captured German tanker. The Panther was magnificent when it worked. Smooth transmission, comfortable seats, excellent optics, climate control. Fighting in a Panther was like driving a luxury car. But it didn't work. Constantly breaking down, transmission failures, engine overheating, final drive problems. We spent more time repairing than fighting. I'd watch Soviet T-34s pass our broken-down Panther. Their crews looked miserable, cramped, uncomfortable, crude conditions. But they were moving. We were sitting beside the road, waiting for parts that never came. I learned, comfortable and broken is worse than uncomfortable and working. The statistical truth wall. Massive wall display presents comprehensive T-34 statistics. Production, 1940 to 1945. T-34 Model 1940, 115 tanks. T-34 Model 1941, 1,110 tanks. T-34 Model 1942, 12,520 tanks. T-34 Model 1943, 15,696 tanks. T-34-85, 1944, 10,952 tanks. T-34-85, 1945, 12,551 tanks. Total, 52,944 tanks, T-34/T-34-85. Additional variants, 4,406 tanks. Grand total, 57,350 T-34 family tanks. Comparative production. Display shows bar graph. Soviet T-34, 57,350, tallest bar. German Panzer IV, 8,553. German Panther, 6,000. German Tiger 1/2, 1,839. US Sherman, 49,234, second tallest. British Churchill, 5,640. Key insight. T-34 and Sherman were the two most produced tanks of World War II. Both shared design philosophy, adequate performance, mass production, reliability prioritized over sophistication. Germany produced excellent tanks in limited numbers. Allies produced adequate tanks in overwhelming numbers. Adequate in overwhelming numbers won. The kill ratio paradox interactive display explores the paradox. Germany had superior kill ratios but lost anyway. Simulation. Visitor can input different scenarios. Scenario 1. Historical reality. German tanks, 32,161. Total. Soviet tanks, 86,350. Total. German kill ratio, 2:1. Destroy 2 Soviet tanks per German loss. Simulation runs. Germany destroys 64,322 Soviet tanks. All German tanks destroyed. Result: Soviet victory with 22,028 tanks remaining. Scenario 2. Improved German kill ratio. Same numbers. German kill ratio, 3:1, extremely favourable. Simulation runs. Germany destroys 96,483 Soviet tanks, more than Soviets had. All German tanks destroyed. Result: Soviet victory with 5,547 tanks remaining. Scenario 3. What Germany needed for German victory through attrition. Required kill ratio, 5.3:1 minimum. Historical kill ratio, talks about to 1 average. Gap. Germany needed to be 2.6 times better than they were. Conclusion. Germany lost not because their tanks were bad, they were excellent. Germany lost because excellence cannot overcome 2.7:1 production disadvantage when excellence is only 2:1 better. T-34 didn't need to be better than German tanks. It needed to be adequate in overwhelming numbers. It achieved both. The designer's vision. Final exhibit focuses on Mikhail Koshkin, T-34's chief designer. Large portrait of Koshkin, 1898–1940, with his design principles displayed. Koshkin's 5 principles of practical tank design. 1. Design for the factory you have, not the factory you want. German designers created tanks requiring precision manufacturing. Soviet factories couldn't provide precision manufacturing, so I designed tank that worked despite crude manufacturing. 2. Adequate performance in mass beats excellent performance in scarcity. T-34 armour isn't thickest. T-34 gun isn't most powerful. T-34 isn't fastest or most comfortable. But T-34 is adequate in all categories, and we can build 10,000 of them. 3. Simplicity enables sustainability. Complex tanks break down. Simple tanks keep working. In long war, reliability matters more than capability. Working adequate tank beats broken excellent tank. 4. Design for worst-case conditions. Russian winter, mud, unskilled crews, crude repairs, limited spare parts. T-34 works in all these conditions. German tanks require ideal conditions. We don't have ideal conditions. 5. The best tank is the tank that exists. Perfect tank that arrives in 1944 loses to adequate tank that arrives in 1940. Timely adequacy beats delayed perfection. Koshkin's death. Display explains. Koshkin contracted pneumonia during brutal winter testing of T-34 prototype, 1940. He insisted on personally driving the prototype 2,000 kilometers in winter conditions to prove reliability. He proved it, then died at age 42. Koshkin never saw his tank win the war. He died before Germany invaded. But his design philosophy, crude, simple, adequate, mass-producible, won the Eastern Front. Visitor comment book shows recurring theme. I came expecting to see the best tank. I learned about the most effective tank. These are not the same thing. The T-34 teaches that perfect is the enemy of good, and good enough in overwhelming numbers beats perfect in limited numbers. German engineering, sophisticated and defeated. Soviet engineering, crude and victorious. I learned more about engineering from this exhibition than from my degree. The final display. The tank at the Reichstag exhibition concludes with large photograph. T-34-85. Berlin, May 1945. Reichstag building, Soviet flag. Caption: the tank that shouldn't have worked. This T-34-85 was built by semi-skilled workers in an evacuated factory using crude materials and basic tools. Its interior is uncomfortable, its finish is rough, its visibility is poor, its transmission requires a sledgehammer. German engineers examined captured T-34s and dismissed them as inferior, poorly made, crudely finished, inadequately designed. They were wrong. The T-34 drove 2,000 kilometers from Stalingrad to Berlin. It fought in every major battle of the Eastern Front. It was destroyed and rebuilt multiple times. It survived 4 years of combat. It didn't survive because it was best. It survived because it was adequate, reliable, and available in overwhelming numbers. Germany built 6,000 Panthers, individually superior tanks. Soviet Union built 57,350 T-34s, collectively effective tanks. This photograph shows which philosophy won. The T-34 is monument to principle. In total war, adequate in overwhelming numbers defeats excellent in limited numbers. Production beats perfection. Simplicity beats sophistication. Quantity has a quality all its own. Germany learned this lesson the hard way. The T-34 taught it to them. Epilogue. The lesson that echoes 2024. Engineering School Lecture Hall. Professor James Morrison teaches mechanical engineering at MIT. He begins his course on design for manufacturing with the T-34 case study. The T-34 is terrible tank, Morrison tells students. Uncomfortable crew stations, poor visibility, crude finish, difficult transmission, inferior optics. Every German tank commander would rather have a Panther. Yet T-34 won and Panther lost. Why? Student raises hand. T-34 was mass-producible and Panther wasn't? Deeper than that, Morrison responds. T-34 was designed to be mass-producible. Panther was designed to be excellent. These are fundamentally different design philosophies. When you design for excellence, you create products that require precision manufacturing, skilled labor, quality materials, sophisticated tools, extensive testing, high cost. When you design for mass production, you create products that tolerate crude manufacturing, semi-skilled labor, adequate materials, basic tools, minimal testing, low cost. In peacetime consumer markets, excellence usually wins. In wartime production, mass production wins. In resource-constrained environments, mass production wins. In emergency situations, mass production wins. The T-34 designers understood they were designing for wartime production. In resource-constrained emergency environment, they sacrificed excellence for producibility. This made T-34's terrible tank by peacetime standards, but winning tank by wartime standards. Modern application. You will face similar choices in your careers. Design the best product or design the most producible product. Optimize for performance or optimize for manufacturability. Pursue perfection or pursue adequacy at scale. The answer depends on context. If you're designing Formula One race car, optimize for performance. If you're designing family sedan for developing markets, optimize for producibility. The T-34 lesson. Understand your constraints. Design for reality, not for ideal. Adequate solution that exists beats perfect solution that doesn't. Morrison shows final slide. T-34 legacy, the principles. Design for production reality, not engineering ideal. Adequate performance broadly distributed beats superior performance narrowly concentrated. Simplicity enables sustainability. Reliability multiplies numerical advantage. The best design is the design that exists. These principles won World War II's Eastern Front. They're still relevant today for any engineering project facing resource constraints, time pressure, or scale requirements. Remember, Germany built Tigers. Soviet Union built tractors with guns. Tractors won. Design accordingly. The end. Final statistics. T-34, 1940 to 1945. Total produced, 57,350 tanks. Production time, 3,700 man-hours per tank. Cost, 32,000 RMM equivalent. Crew comfort, poor. Manufacturing quality, crude. Reliability, good. Strategic impact, decisive. German Panther, 1943-1945. Total produced, 6,000 tanks. Production time, 55,000 man-hours per tank. Cost, 117,000 RM. Crew comfort, excellent. Manufacturing quality, excellent. Reliability, poor. Strategic impact, insufficient. The verdict. Crude but mass-producible, defeated sophisticated but limited. Adequate in overwhelming numbers, defeated excellent in scarcity. Soviet design philosophy defeated German design philosophy. The T-34 won not by being best, but by being enough. The lesson. Strategy beats technology, production beats perfection, simplicity beats sophistication, quantity, when adequate, beats quality. Germany forgot this. Germany lost. Don't repeat their mistake.